Hey guys, welcome to Selective Preparation Power Mathematical Reasoning for Test 2031. So today we're just going to go straight in as usual. So let's get started. Jenna dances clockwise around the maypole, making one revolution every 5 seconds. Starting from a point diametrically opposite Jenna's starting point, Allison dances anti-clockwise, making one revolution every 6 seconds. How many times do they pass each other's starting points in the first 6 minutes? Now, the first word that should pop up in your radar is this, diametrically opposite, right? What does diametrically opposite mean exactly? Well, luckily for us, it's already in the diagram. It's dia, meaning two, and opposite, so facing each other, right? So we have this situation where Allison runs anti-clockwise in that direction, Jen runs clockwise, and we're also given their respective speeds. So Jenna runs at 1 revolution per 5 seconds, and Allison, not Jenna, Allison takes 6 seconds for 1 revolution, okay? And each revolution, right? Each revolution, they're going to pass their starting point or the other person's starting point once. For example, Allison's starting point is here, isn't it? For Jen, then, traveling 1 revolution across would pass Allison's starting point only once, right there. So for 1 revolution, starting point is passed once, okay? And this is just that key point you need to know. If that's the case, then we know that if we just divide however many minutes, 6 minutes, so 6 minutes equals to 6 minutes, I should write, equals 360 seconds, right? Because each minute is 60 seconds. So if we divide 360 by 5, we should be able to, and that's Jenna's rotation speed. If we get that, we should get the amount of times, not 6, oops, 7, 35, we should get the amount of times that they pass the other person's starting place. 60 times. Right? So, and the question asks, how many times do they pass each other's? Meaning that we get both of them and add these up. So 72 plus 60 would be 132 times altogether. Okay? And so the answer is D. Right, let's go on to the next one. Question 2. A list of 10 numbers contains 2 of each of the numbers, 0, 1, 2, 3, and 4. The 2 2s are next to each other. The 2 1s are separated by 1 number. The 2 2s by 2 numbers. The 2 3s by 3 numbers. And the 2 4s by 4. The list starts 3, 4, dot, 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 dot. What is the last number? Now, this question, not necessarily hard, but the only difficult section is understanding what it's saying itself. So let me clarify that 0, 1, 2, 3, 4 are the only sort of numbers we're going to be using, not 5, not 6, nothing like that. And also, the question doesn't mention this, but it is only a single digit. Okay, I think it would have been better for the question to mention that all the numbers are a single digit, because when I read it for the first time, I assumed that it was any combination of 0, 1, 2, 3, 4, because it just says a list of 10 numbers. But yep, number 1, it's single digit, and so let's follow along from there. The 2 zeros are placed next to each other, so we know no matter what it comes up. The important part is here. We start with 3, 4. And also, guys, when we do a list, normally, for example, a to-do list, we say we go vertically down, don't we? We list our points, blah, 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 and we say this is a list, or list. But here in lists in maths, we're talking about any accumulation of numbers. So that can be horizontal or vertical, but in this case, it is horizontal. 3 comma 4. And how do we know that? If one doesn't work, if this way doesn't work, then surely this way must work. So it's a bit of trial and error there. Anyways, we start with the two numbers, 3 comma 4. Then what do we go with? This is the first place, second place, third place, fourth, fifth, sixth, seventh, eighth, 9. And let's create space for one more. So get rid of these. 1, 2, 3. Okay. So in total, I have 10 spaces there. Hopefully I've counted right. Yep. And the first two places are taken by 3 comma 4. What else? What else can we put? Well, let's continue with the pattern because we already know. If 3 is the first place, then after 3 gaps, that is 1, 2, 3, we should have another 3 sitting here, right? Because what does the question say? The two 3's are separated by 3 numbers, right? Which is the red arrows, 1, 2, 3. The 4 then is separated by how many numbers? 4 numbers. So let's draw that. 1, 2, 3, 4. So number 4 should go here. Okay. Let me rub out these arrows so that I can show you other things. Next, what is the next possible options we have? We still have the numbers 0, 1, 2, right? But we don't know which order to place them. So what do? We list out options. Whenever we're given these sort of open-ended questions, we should list out our options first. So let's see. For 1, the number 1, where can we put it? Let's just write it down. We need 1 space. Right? If we need 1 space, what possible options do we have? We can put number 1 here, or we can put number, and if we do that though, actually we can't do that there. If we put number 1 here, we can put oh guys, I just realized I made a mistake here. Apologies. 4 should not be here because 4 spaces from the first 4, 1, 2, 3, 4 should actually be here. Okay. Apologies. Anyways, let's get back to the place. If the number 1 needs 1 space, what options do we have? We can put number 1 here or here. Not or, sorry, and here. Then we also have here and here. And finally, these two options. Okay. But we also have what number? 2. So these guys need 2 spaces. We also have 0 who needs no space, but I've ignored that for a reason. I'll show you why. So number 2 need 2 spaces, right? I'm going to do that in blue. If I need 2 spaces, I can put number 2 here and put the other one here. One here and the other one here. Okay, but that's about it. Now let's choose the option that has the most criteria or is hardest to find, and that would be number 2, wouldn't it? Right, because it needs 2 spaces, and spaces is the exact thing that we lack of, and so we should choose the one with the most criteria. So as long as that fits, everything else should fit as well. So let's try this first option, first blue arrows, pair of arrows. If I put 2 here, I'll do this in blue so you don't get confused. If I put 2 here, 2 here, I suddenly have a huge gap here. Oh, that shouldn't be 0. Here and here, which none of the 0s or 1 can fill up. Can you guys see that? Okay, so I already know that this option, the first pair of arrows, is not the right blue for me. Okay. In fact, if it's not the first one, then it has to be the second one, doesn't it? So let's put down 2 and 2. If that's the case, the only other viable options that we can place 1 is where? It's gonna be here. That do right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yep. The only viable options to place 2 would be here, sorry. Then 1 should only go here, right? Because otherwise, if we didn't do that, guys, where would 1 go? Here? But that doesn't make sense. 1 needs to be separated by 1 further space, which is the if 2 is here, then the only viable option for number 1 is next to the final 2. Okay? And obviously when that takes place, 0 correspondingly just comes naturally. So this is the sequence of order that we have with our list of numbers. Okay? So the question, back to the question. The list starts 3, 4. What is the last number? That is obviously then 1, which is option E. Okay. Let's move on to question 3. The ferry boat is full when it has 10 cars on board. It is also full when it has 6 trucks on board. The ferry boat never carries trucks and cars at the same time. The ferry boat made 6 trips across the river and was full on each trip. It carried a total of 48 cars and trucks across the river. How many trucks did the ferry boat carry all together in the 6 trips? Okay, this question, unfortunately, is best solved by trial and error. Okay, there is an algebraic method. However, that is far too difficult and complex for the sakes of this problem. Okay, so let's have a start. Let's choose any option. Option D. I just chose randomly. If it was 36 trucks, right? Actually, maybe I shouldn't do that. That looks like division. If I had 36 trucks, right? And cars. And how many cars would I have? Let's see. Guys, if I draw a line, if I had 36 trucks, then out of the 48 trucks and cars, I should have 12 cars. Okay? And 12 cars corresponds to how many trips separately? If there's if the ferry boat travels when there's 10 cars on board, that means we'd have to divide 12 by 10. But we can't do that, right? Because we can't have 1.2 trips. The question specifically states that we should have full trips each time. And together those trips should total have 6 trips. But because already the trucks would consume 6 whole trips itself, because remember, each trip itself with trucks, you need 6 of them. And there's 36 of them. So if you divide it by 6, we should get already 6 trips. But it says here that what? It carried a total of 48 cars and trucks, but it only took 6, meaning that this option D is probably way too big. Right? So you rub that out. Don't want that. Definitely don't want that. So we come back. We say, all right, let's choose option C, 30. If 30 is the case, 48 minus 30 would be 18 cars, right? Because remember, this is trucks. 18 cars. Again, if I divide by 10, right? This cannot be some whole number. And if it was 30 trucks and I divide it by 6, this is 5 trips, okay? So together they do not equal to 6, so therefore I must choose another option. What option might that be? Let's see. Let's choose option B, 18. 48 minus 18 trucks should be 30 cars. If it's 30 cars and 18 trucks, let's see how many trips for trucks it takes. Divided by 6, I get 3, right? If I divide 30 by 10, because 10 cars, I get 3 as well. And huzzah, we have gotten 3 plus 3 trips, which is 6 trips, which corresponds with the question. And therefore, our answer is B. Okay, guys? So make sure, if you're not sure, just try trial and error. Most often than not, that should be the quickest route. And remember, all this should be taking within perhaps 5 seconds. Okay? All this process of thought should be happening within first 5 seconds. to decide to do trial and error, and probably the next about 20 seconds trying to figure out which option it is. The only reason it takes this long, again, is because I'm explaining it, trying to make sure that visually everyone can see as well. Next, question 4, volume. A lump of metal is submerged in a rectangular piece 20 centimeters by 15, raising the water by the level 0.35 centimeters. What is the volume of the metal piece? Now, this question is definitely not difficult at all, but it's just the idea that volume displaced, or in other words, volume that is added or moved, right, is volume of the object. Okay, if I were to give you guys a fish tank, right, a fish tank, and I'm not going to list the values of it. If I have a fish tank and obviously it's full of water, and I place a brick in it about this big. If I place a brick in that big, the amount of space that this brick normally takes up in air, right, is then going to be inside the water, which must mean that it pushes the water away for however much volume the brick itself takes up. Okay? That must mean that the water level must rise corresponding with the amount of volume that was displaced by the brick or moved by the brick. Okay? Because obviously when we push on water, it moves away from the brick, right? Because this brick can't be made of water, right? It's always going to be made out of, I don't know, cement or whatever it is. So because it displaces the water around it, the water levels must also go up. Does that make sense? All right, so hopefully that concept makes sense. So if volume displaced equals to the volume of the object itself, then our calculation becomes easy. 20 by 15 by the amount of water it rise, 0.35, must be equal to our answer. And this is 105 cubic centimeters. Okay, guys? So this is option B. All right, final question. If the Carlton won 15 of their games and the Collingwood won 12 of the 30, which team had the better record? This would just be comparing fractions, wouldn't it? So 15 of the 45 versus 12 of 30, I should say. 12 of 30. Now, instead of finding common denominator after simplifying, well, actually, let me just show you first before talking. I can do it two ways. I can say, 15 over 45 is 1/3. That's easy. And the other option is simplified. I get 6 out of 15, which is 2 over 5. And now let's find a common denominator here. We could do that. That's also correct. But look at the denominator numbers. It's 45 and 30. What is the lowest common multiple you can find of 45 and 30 straight away? It should be 90. Okay, so that's so much easier because you just times 2 to 15 over 45 and times 3 on top and bottom for 12 over 30. Okay? And obviously, which one's bigger? 36. So, Collingwood wins. Okay, guys? So, whenever you're comparing fractions, make sure the denominator is the same. But in these certain situations, I recommend not simplifying first because we already have lovely numbers 45 and 30. Okay? And so, answer is B, Collingwood. Alright, guys. Welcome to the key points from this test. So, key point number 1, list write out options. I draw this from question number 2. Remember how we had many options that we could choose from when the numbers weren't filled out here? Just write them out because I can't stress how important it is to write them out so that you don't have to put that much stress on your brain when you're thinking, and chances are you'll probably help yourself doing that and getting the correct answer. Point number 2, volume displaced is volume of the object itself. I went into some detail about why this is the case, but essentially if you remember that however much volume that an object takes up in water is how much the volume takes up in normal air as well. As long as you know that, all these sort of questions should be fine. Point number 3, comparing fractions require a common denominator. It's quite obvious, but just keep that in the back of your head. Don't try to guess. Always make them the same and then try to compare them there. Okay, guys? Well done, and I'll see you next.